So in this video, we're going to be determining the rate law with reaction mechanisms. So here I have a theoretical formula which has 2a plus 2b equals c plus d. And so this can be separated into three different elementary steps. So the first step would be a plus a goes to x. And then the second elementary step being x plus b goes to y. And the third step is y plus b goes to d. Okay, so as you can see with these elementary steps, the x would cancel out and the y would cancel out. For determining the rate law for a reaction mechanism, what we want to focus on is which is the slowest step. And out of these three elementary steps, which is the slowest step? So we were given this information. So the first step was fast, and the third step was fast as well. So the slowest step would be the second elementary step. So the way that we're going to determine the rate law for this is we're first going to have the rate. We're going to determine the rate laws for each elementary reaction, and we do something different with reaction mechanisms in that we determine the rate law using the coefficients, which we're not supposed to do whenever it's not a reaction mechanisms because we can only determine the rate law through experimental data, but it's a little different for these reaction mechanisms. So for the first rate law, we would have the rate equals K times A, because it's second order with regards to A. It's for the second reaction, or second elementary step, the rate law would be K X B. And then the third rate law for the third elementary step would be okay, and so since we know that the second elementary step is the slowest step, we're going to focus on this for determining our overall rate law. And so problem that we have with just having this is that we have x, and if we added together these three equations, x is consumed by the reaction, so it wouldn't be inside of that. And so we see that through the first elementary step that x also goes to 2a, and so we can substitute this 2a in for the x in this rate law, and so we can use that to find the overall rate law. And so by substitution, the overall rate law of this reaction would be and you can see that I substituted this 2a value in for the x value because of the first elementary step.